My fabulous chemistry minions, video number 6. Today we're going to start in on electrochemical cells, basically batteries. So we got to find out all the parts, and we're going to put some half reactions involved and see what's going where. And there's a bunch of testable little things about these electrochemical cells that we all need to know. So here we go. First off is voltaic cell, and this is one that will have this the little voltmeter up top. You see the V. This picture is going to be very important for this lesson. These all use spontaneous reactions to take stored chemical energy and turn it into electrical energy. And then electrolytic is the other kind of cell, and this one is a non-spontaneous reaction, and it needs electricity to make it go. Okay, so somehow we need to know that electrolytic needs electricity. You've got to remember that somehow. Then we get into the actual electrodes. The electrodes you can see, and they're labeled in the picture. I have a magnesium electrode and I have a copper electrode. They're solids. So they're all pure elements. So they're going to have an oxidation number of 0 every time in our redox reactions. Okay. Then I got to remember how to assign which one of the electrodes to which process. So this is what we use. We use a red cat angry ox because the anode, angry, goes with oxidation. Anode is where the oxidation takes place, and it's the positive electrode where oxidation takes place. Stuff you got to memorize. Okay. Now we'll get into red cat. The cathode is where reduction takes place. So this is the acronym we use to keep this straight. The cathode is the negative electron where reduction is going to take place. So red cat, reduction, cathode. Red cat, angry ox. That's how we remember which goes where. And then the electron flow always goes from anode to cathode, A before C. So it always goes A to C, anode to cathode. Okay, anode to cathode, anode to cathode. And this is a great question. You do have to memorize this. You can see in the picture there is this thing called a salt bridge. And this is going to allow the ions to flow or complete the circuit. Those are either of the two correct answers. The allowing ions to flow is the #1 correct answer that I need you guys to be able to produce when asked, and they ask this a lot. What is the function of the salt bridge? It's to allow ions to flow. They're going to try to trick you to say it allows electrons to flow, but electrons do not flow through there. They only flow through the wire from the anode to the cathode. Okay. Now, same picture we've been doing before, but notice at the bottom it has the half reactions or the whole reactions for us down here. So I'm going to use this reaction to build the half reactions and put this whole electrochemical cell thing together. Ready? So from down here, I see Mg solid, and Mg solid, remember, is going to have a 0 because it's just a lone element. Okay. And then I have copper +2 going to Mg +2, and then copper 0. I'm going to put zeros go ahead and put zeros on my lone elements. And from there, I can do the reduction first. And I can see that from going to 0 to 2 is going up. So Mg is not being reduced. Copper +2 going down to 0. There's my reduction. So I'm going to go ahead and fill that in first. Left-hand side of the arrow is Cu +2. Right-hand side of the arrow is Cu 0. There's 2 electrons in play because of going from 2 to 0. So I'm gaining 2 electrons. Oil rig, reduction is gaining. The oxidizing agent is the reactant in the reduction half reaction. So Cu +2, right? And 2 electrons are involved. This is kind of a review of video 4. So nice. And then I got Mg0 now is being oxidized. Mg0 is on the left-hand side of the arrow. Mg +2 is on the right-hand side of the arrow. From 0 to 2 is 2 electrons. My electrons jive, so I'm good. All right, and then I have my reducing agent then as the Mg0, moles of electrons, 2 electrons. I don't have to balance. Everything is good. And we are basically donezo with the video. I just put in a nice big picture here of this voltaic cell so we can see what's going on. Notice that there is a wire going through a voltmeter. That V is a way to tell this particular electrochemical cell voltaic from electrolytic. There won't be a voltmeter in an electrolytic. The other one is the salt bridge. There's only a salt bridge in a voltaic cell. Also notice that there is 2 beakers. There's a beaker of the Mg+2 solution aqueous in water and a solution of the Cu+2 aqueous solution in the water. Notice how there's two beakers with one electrode in each. Another giveaway that this is a voltaic cell. And then the electrons are going to flow from the anode to the cathode. So in this case, it's going to go from your left to your right, but I don't want you to answer left to right. I don't want, all right, that's not how we do these. We answer Mg to Cu, or you say anode to cathode. The correct answer is always anode to cathode, so you don't even have to tell me which one is the anode and cathode to get that one right. You know what I'm saying? So the electrons are going to flow through the wire. And the simulation that's part of your packet is a great place to really watch what's going on here, because it's going to show you, it's going to like zoom in on the electrodes and show you what's going on with how the electrons leave and form Mg pluses. So if Mg0 loses electrons, he makes an Mg plus. The Mg plus is going to fall off into solution and join his friends Mg pluses, and the electrons are going to take off and go down the wire. Then the Cu over here is going to not necessarily take on electrons. The electrons are going to flow right through into the solution, and the electrons are going to go into that Cu+2, making it Cu0, and then that copper 0 is pure, pure elemental metal atom, and it's going to cling right onto the copper electrode, and that electrode's going to grow, and the magnesium electrode is going to shrink. And the tutorial really is a great way to show you how that happens. And since I'm not live in class to walk us through the smartboard and show it to you, I want to make sure that you see those links and that you watch that the best you can. So I'm going to check it out today, post the links up with this particular video, and if it's not working on Chromebooks, let me know and I'll record it on my computer and just post that video. Okay, so with that, I think we are done. So see ya.